Hi, this is John Isles, and welcome to Geometer's Paradise. Today we're looking at the 3-3 solutions video. We're going to look at the practice problems. I filled out the rest of the document during the lesson video. So here we have the original statement. If two lines intersect to form congruent adjacent angles, then they are perpendicular lines. Pardon me one second. And we know this to be true. We've proven it true many times in class. The converse is if two lines are perpendicular, then they intersect to form congruent adjacent angles. We also know that this is true. Again, we've proven it in class before. Lesson 2-2 or 3. All right, the inverse, if two lines do not intersect to form congruent adjacent angles, then they are not perpendicular lines. All right, this is also a true statement. This statement is true because the converse is true. The inverse has to be true. It doesn't matter what it actually says. It has to be true. The contrapositive will be if two lines are not perpendicular lines, then they do not intersect to form congruent adjacent angles. Because if they did, then the original statement would be false. So that would be bad. All right, so this is true. So can this be a biconditional? Yes, it can. And it would be if two lines intersect, it would be two lines intersect to form congruent adjacent angles if and only if they are perpendicular lines. Okay. If C is between A and B, then AC plus CB is equal to AB. This is the segment addition postulate. It is a true statement because it is a postulate. All right. Converse. If AC plus CB is equal to AB, then C is between A and B. Okay, this statement is also true. And the reason why is because if AC plus CB is equal to AB, then C has to be between A and B. It can't not be between A and B. And the reason why is that if it were not, then it would be a triangle. And if it were a triangle, then AC plus CB equals AB would not work. So this is also true. Inverse. If C is not between A and B, then AC plus CB is not equal to AB. This is also a true statement. And again, this is because if two segments add up to be equal to the third, it's between. So this is true. Finally, if AC plus CB is not equal to AB, then C is not between A and B. This is also a true statement, and this is definitely biconditional. Okay, if a tree falls in the woods, it makes a sound. I'm going to say true. This is true. All right, now, converse. If a tree makes a sound, then it falls in the woods. Okay, can trees make sounds and not fall down? The answer is yes. They can creak back and forth in the wind. They make that weird creaky noise. They're not falling down. They're not crashing to the ground. So that's a false statement. The inverse, if a tree does not fall in the woods, then it does not make a sound. Again, tree's not falling down. Can a tree not fall down and make a sound? Yes, it can. So this statement is false. And the contrapositive, if a tree does not make a sound, then it does not fall in the woods. Okay, so if a tree is making no sound at all, is it falling down? The answer is no. The tree is not falling down. So this is true. No sound, no falling tree. But can this be a biconditional? No. Finally, if AD bisects angle BAC, then angle BAD is equal to angle DAC. This is the definition of a bisector. So this is a true statement. It's a definition. Now, if angle BAD is equal to angle DAC, then AD bisects angle BAC. Okay, again, yes, this is true. This is defining bisector, and we cannot draw. These angles are adjacent, okay, because they share D and A. Their vertices are the same. They have a common side. These are adjacent angles, and they're equal. That's the definition of bisector. The inverse, if AD does not bisect angle BAC, then angle BAD is not equal to angle DAC. Okay? Also a true statement. Finally, if angle BAD is not equal to angle DAC, then AD does not bisect angle BAC. Also true. And can this be a biconditional? Yes. So there you have it. There's a look at related conditionals, converse, inverse, contrapositive, and biconditional, and how we go about reasoning whether or not they're true or false statements.